Today I will explain assignment 2.3 of the physics of first year. This assignment is consisting of the takeoff of an aircraft that is JF-17 Let's see. First of all, I will explain the statement of the question. A joint fighter 17 JF Thunder 17 aircraft takes off at 70 meters per second after accelerating uniformly at 3.9 meter per second square from rest. That lasts 6.5 seconds during initial phase of takeoff. Up to this statement, we will consider first phase. During this, since the aircraft starts from rest, so its initial velocity vi1 will be taken equal to 0. During this, the acceleration of the aircraft is 3.9 meter per second square, and aircraft moves with this acceleration for 6.5 seconds during the first phase of movement. Then burner of the engines are then turned up to full power, which creates which increase the power, and aircraft starts moving with an acceleration of 77.1 meter per second square. This is the second phase during which the aircraft moves with greater acceleration. And then finally, the at the end of the runway, the aircraft takes off with 70 meter per second velocity. Now we will calculate two things. Number one, length of the runway and time taken by the aircraft to take off. Let's see. The runway is consisting two parts. The first part of the runway is this, and this distance is taken S1. We consider S1 for this length. This is the first phase distance, which is covered by the aircraft, and it is considered S1. Now, when engine starts uh, with high speed and aircraft gains this acceleration 7.1 meter per second, that is started from this, that is second phase. And the distance covered by the aircraft during the second phase is taken as 2. Now, acceleration for phase 1 is A1, 3.9 meter per second square, and acceleration for phase 2, that is consisting of phase 2 distance S2. Now, that is 7.1 meter per second square. Now, time taken T1 for phase 1, and that is 6.5 seconds. During this time, distance covered by the aircraft is S1. This is the first phase distance. Then final velocity for first phase, that is at the end of the first part of the runway here. The velocity will be Vf1, Vf1 for phase 1. We will find first this. We will also find the length of the runway, which is consisting of two parts. For first phase, the distance covered by the aircraft is S1, and for the second phase, distance covered by the aircraft is S2. During this, the aircraft moves with different acceleration, that is 7.1 meter per second square. While in the first phase, the aircraft moves with uniform acceleration, that is 3.9 meter per second square. So we will find this distance, total distance S1, which will be consisting of the sum of two distances S1, S2. Also, we will find the total time taken by the aircraft to take off. T1 is the time taken for first phase for this length of the runway, and this second phase movement, the time T2 is taken by the aircraft for this second phase of the motion of the aircraft. First of all, we will find the distance for the first phase of takeoff, that is S1. We will consider the equation S is equal to S1 is equal to V1 I1 T1 plus 1 by 2 A1 T1 square. We know that initially the aircraft was at rest and its velocity was Vi1 is 0. So Vi1 will be replaced by 0. And time T1 is the time taken by the aircraft for the first phase, that is S1, and it is its value is 6.5 seconds. So T1 will be replaced by 6.5 seconds, and acceleration A1 for the first phase is also given, that is A1 is equal to 3.9 meter per second square. So A1 will be replaced by 3.9 meter per second square. T1 square will be T1 will be the same time as for the value for the first phase, that is 6.5 centimeters. So we will put the values of these variables in the equation and we will get this equation. The simplification of this equation will give us the result, that is S1, 82.38 meters. This is the distance which will be covered by the aircraft during the first phase of motion. So now we will find the velocity as well for the first phase. For the first phase, initial velocity was 0, and for the same first phase, final velocity will be Vf1 here. We will also calculate this value, that is Vf1 Vi1 plus A1t. This is for first phase. So put the values of these values. V1 Vi1 for first phase is 0 because the aircraft was initially at rest, and then it starts moving with uniform acceleration, that is 3.9 meter. Time for the first phase of motion is 6.5. Simplification will give us this result. This is the final velocity of the aircraft for first phase. Now, for second phase of takeoff, the distance will be considered S2, can be calculated by using this equation of motion. Now, A2 is also given for the second phase. Distance S2 will be found by us. Vf2. This Vf2 is basically the final velocity of is equal to the final velocity of first phase. That is Vf2 is equal to basically Vf1. So Vf1 final velocity of the aircraft for the first phase will be taken Vf2 for the second phase. This will be the initial velocity. This will be the initial velocity for the second phase. So Vi2 will be taken equal to Vf1 of first phase, the velocity of the aircraft for the first phase. Vf2 is given, that is equal to 7 point some 7 point. Now that is 70.0 meter per second is the speed of the aircraft when aircraft takes off from the runway. This is the final velocity during the second phase, and initial velocity of the aircraft during the second phase is Vi1, which is equal to Vf1, that is the final velocity during the first phase of the aircraft. So we will put this value 25.35 in this question. Simplification will give us the distance of second phase covered by the aircraft. Now total distance covered by the aircraft on the runway is the sum of the two distances S1 the distance covered by the aircraft during the first phase, plus S2, the distance covered by the aircraft phase 2. So these two results will give us 382.2 meter. Now, for second phase of takeoff, we will find the time by using the equation of motion. Since Vf2 is given, that is 70, with which aircraft takes off from the runway, and Vi1 again 2 is equal to the final velocity of phase 1, that was Vf1. So it is again same 25.35 plus acceleration for second phase, that is 7.1. T2, we will find T2, time taken by the aircraft for the second phase distance. So simplification will give us T2. So the total time taken by the aircraft to move from start to end, that is equal to T1 plus T2. That is total time taken for takeoff. T is equal to T1, T2. Add these two times, we will get the time taken by the aircraft for taking off the runway. That is the end of this question. Thank you so much.